Hello, welcome to chapter 3. So, we are now going to be starting polynomial functions. So, today we're doing 3.1, which is analyzing polynomial functions. So, we're going to be looking at every part of the polynomial function, how to name it, how to graph it. And so, in class, you'll be able to answer that in the chat box question, but let's go ahead and go to some examples. So, 3.1 day 1. So you'll be filling out your guided notes. We're going to go ahead and start with looking at just what is a polynomial. So you guys have seen polynomials for a very long time now. And so to give you an example of what a polynomial is, just so you can kind of see it, here's one, 2x squared. Another one would be 2x squared plus 5x minus 7. So those are both polynomials, and you've seen those for quite some time now. I'm going to change this 5 to a 3. Not that it extremely matters, but just so that I'm consistent with what I do in class and in this pre-recorded. So here's one, and here's another one. So what is a polynomial? Well, in math terms, a polynomial is a monomial or the sum of monomials. Oops, got ahead of myself there. Okay, so, what's a monomial? What's the sum of monomials? Well, let's look at our example. This right here is one term. One term or one item. So there's no plus or minus here. It's just one item here. One term is what we're going to call them. And so that means it's a monomial. And then here, this 2x squared plus 3x minus 7, this right here we said is one term. Here would be a second one, and this would be a separate one again. And they're all being added or subtracted in this case here. But this would be a polynomial with 3 terms. But it's still a polynomial because they're sums. Okay, so each monomial is one term. So like right here, if we're classifying polynomials, if it has one term, remember we said terms are monomials. So we said an example could be 2x squared. That's one term, and we called that a monomial. Okay, 2 terms would be if we added something to it. So 2x squared plus 3x. There's 2 terms, and we call this a binomial. And then 3 terms would be this right here. So 2x squared plus 3x minus 7. That's 3 terms, and that would be a trinomial. And then when we have 4 or more, we just say polynomial with blank terms, however many there are. So this answer here would go right here. Okay, so that's half of your classifying, but then you also need to use the degree. Well, what's the degree? The degree is you're looking at the exponent. So this here. So the degree, and we'll have this definition on the next slide actually. You look at the exponent. Okay, and we'll do some examples as well. But if you have a 0 degree, so like x to the 0, that equals 1. And this would just be a constant. So it would be a straight line, horizontal or vertical. And then x to the 1 would just be x. And so that would be called a linear line. So it's going to be a diagonal line, excuse me. And then going up, so x squared would be our quadratic that we dealt with last chapter. And then the third degree would be cubic. Fourth degree would be quartic. And it just keeps going up. And then 5 would be quintic. Oops. And just like if we had 4 or more, we just left it as 4, or whatever number we have of terms. For 6 or more, you'll say polynomial of a blank degree. So whatever you have here goes here. Okay, so again, if this is a lot of information and I'm well aware of that, we're going to do some examples in just a minute. Right now we're just going over all the definitions and getting all of that in front of us, and then we're going to be doing some examples to apply it. So let's go ahead and look at some more definitions. I know, that's the boring part. I'm sorry. So more definitions. So we're going to look at just what is the standard form of a polynomial. And so standard form of a polynomial is going to be that polynomial, the terms, written with the degrees largest to smallest. In other words, descending order. Okay, so standard form, you're going to write the exponents from greatest to smallest. And then we've already talked about it a little bit, but degree of a term. So when you want the degree of a term, you don't just look at one exponent. So an example that we'll look at on this slide is if we have 6xy to the 7th plus 3xy squared minus 5y. So when I'm trying to find the degree of a term here, I'm going to change to purple. I'm adding all the exponents in that term. Okay, so for instance, this is one term right here, and I would need to do the 1 plus 7. And so this degree of this one right here would be 8. And then this one, we have a 1 here again, and so it would be 1 plus 2, which is 3, and then this one is 1. So the degree of this one here is 8, this one is 3, this one is 1, and so this is in standard form because it goes from greatest to smallest in terms of the degree. So let's look at the next one, degree of a polynomial. So these each have a degree. To say the degree of the entire polynomial is you look at the largest. So the degree of a polynomial is the greatest degree of all the terms. Okay. And then later on, when we're looking at more information, we're going to need to know the greatest, or excuse me, the leading term, what the leading term is. And so the leading term, we're going to be looking at the term with the greatest degree. Sorry, I can't write as fast as I can talk. Greatest degree. And then the leading coefficient is going to be the last thing that we need to know in terms of definition, and that is going to be the number in front of the leading term. So in this case right here, the leading term would be 6xy to the 7th, and then the leading coefficient would be the 6, the number in front, which is 6. Okay, so I'm going to go ahead and end this one. Or actually, I'll do one more slide and then I'll have to do another video for the second part. So let's look at this one here. We want to write it in standard form. So we're first going to identify the degree of each term. So we're going to do the degree of each term. So this one right here would be 1 plus 1. So this would be a 2. And this is a 2. And this is a 2. So all of these are 2's, which isn't a great example to start with. So we're actually going to cross this out. So again, we're going to cross this out and we're going to rewrite it. Okay, so here it is rewritten like we want, 6a squared b to the third minus b squared plus 4a squared times b. So now we're going to find the degree. So this one right here would be 5. This one here would be 2. Again, I'm adding my exponents. So 2 plus 3 gave me the 5. This one only has a 2. And then this one right here would be 2 plus 1, which would be 3. So now I'm looking at my degrees and I'm going to rewrite it in standard form. So largest to smallest degree. So the largest one is 5. So we'll go ahead and rewrite that. 6a squared times b cubed. And then the next one would be the 3, so plus 4a squared times b, and then minus b squared. So now it's in greatest to smallest or descending order for the degree. And then the next thing, I'm going to jump down to leading coefficient. So what is the number in front, which in this case is a 6? And then what is the degree of the polynomial? So we said the largest degree was 5, so the degree is 5. Okay. Another thing to note is it might be helpful to just say number of terms. So how many terms are there? And in this case, we have 1, 2, 3. We have 3. So to name it, to say what it is, we have 3 terms. So we have 3 terms, so it's a trinomial and a degree of 5. So it's a quintic trinomial. So again, quintic trinomial. All right, so there it is, quintic trinomial. Go ahead and pause the video, try the next one, and then check your answer. All right, so check your answer. So the first one would be a degree of 5, and the second one a degree of 4. So it's actually already in standard form. And then the leading coefficient is that 2, the number in the front. Degree, we said the largest number was 5, so the degree is 5. And there are 1, 2 terms. We found the degree of 1, 2. So we have quintic binomial. Quintic, again, represents the 5th degree, and binomial represents the 2 terms. So go ahead and check back for part 2, because I ran out of time.